This video is going over a problem from the Building Java Programs book, and we're looking at Chapter 8, which is about classes, and Self-Check 6. We have a whole bunch of descriptions about what is the difference between a field and a parameter. So they're asking the difference between a field and a parameter, and let me just quickly switch over to Eclipse and so we can be clear about what we're talking about. So I've created a simple test class here. The test class is the driver class, and I've got a class here called myTest. And so we're talking about fields. So here's a field here, which is declared outside any of the class's variables. And then they want to compare a field to a parameter here. So a parameter is something you pass into a method. By the way, so they call these fields, the various languages, many languages are object-oriented languages, and they all have slightly different names. The Building Java Programs book calls this fields. I call them member variables. There are various other names as well. But instead of looking, so fields definitely we want to look at, but instead of comparing it to parameters, which is fine, I really like to compare it to a local. And actually, let's just remind ourselves what's the difference between a local and a parameter. There's actually very little difference, okay, because a local and a parameter are both scoped within these brackets here. Okay, that's where they exist. And there's no difference in how you declare them, okay, whether you declare an int here, or you declare an int here, or a string, or anything you want. They're used exactly the same way once they're declared. Okay, the only difference is that this int parameter here is a local variable which is passed in. Okay, so for all intents and purposes, I consider parameters to be local variables. It's just a question of how they get initialized. With a parameter, they get initialized by the calling method. Here, my method 5. So it's in effect the exact same thing as if I had declared int parameter as a local and then assigned it to be 5. But of course, you can't do that dynamically so that it can take any different number of methods. But statically, that is the same thing. So what is the difference between a local variable and a member variable? And this is a very good problem, or not a good problem, but it's a very common problem that students have. So let's review this. So what's the difference between a local variable and a field? Well, first of all is what I referred to earlier as scoping. So a local variable is scoped within the braces of the method. Okay, it's only available here. So in addition to this, we could have another method we have my method 2, right? So my method 2 here, local and parameter, don't exist within here, okay? So that's different. Whereas field, any field is actually scoped within these brackets for the entire class. So any method can have access to a field. Okay, so that's one thing, is the scoping. Another is when are fields, when are they created? Okay, a local variable, whenever you call a method, the local variable is created. Okay. You also may remember that there is this thing called static, right? When we have main, we always do static. What static says is that this method can be called without ever creating a without ever creating an object. Normally, you'd have to go through a constructor, okay? If you have a static function, you don't need to call a constructor and create an object before you call this method, all right? But assuming that it's not a static function, okay, it's a method on the class, then you must call a constructor just like this. Okay, so here this myTest object is created when I call the constructor here, and there's actually a default constructor, so that's why I didn't actually fill it in. You have to call the constructor, and then only after you called the constructor can you actually call my method. Okay. When you call the constructor, that's when the field comes into existence. Okay, before you call constructor, this the field doesn't exist, and you cannot call this method. So to review, that one was the difference in scoping, 2 was the difference in when it exists. Okay, a local variable exists anytime you call the method, and you can call the method anytime. Okay, whereas a field only exists when you call the constructor, and then is available to any function, and it survives. Again, it's an issue of scoping, but it survives between method calls, right? So you call my method, and then at the very end of the program, assuming you still hold on to this m, you call my method 2. Well, field still exists. It still has that same value, okay? It's almost like a global variable in the old days. So those are two of the differences. Also, remember that you can make these private. Okay, when you make it private, that means that when someone out here tries to access, let's say sys out of m.field, okay, this is going to throw up an error. The test, the field myField.test is not, or field is not visible, right? So by making them private, you can prevent people from accessing them. That's one thing you can do with member variables you can't do with local variables. Also, you can, if I took this as the name field, okay, not file, but field. All right, how do you access field here? The member variable field, not the local variable field. Well, you can use this.field. Okay, so that's another difference between locals and member variables. But really, the thing that I want to convey to you most of all, let me undo those changes, is the main difference between a member variable and a local variable. Okay, is a member variable is created with a class creation with this new. Okay. It's created only at that time, and then it exists as long, whereas it exists as long as this item exists, okay? So if I have, 1,000 lines of code down here, then, oh, that's interesting. It won't let me do that. Let me try commenting out, okay? So I have 1,000 lines of code here. Later on down here, I can say m.myMethod2. Okay, and it not only does m survive, but that m.field survives with the same value. Okay, whereas a local variable or a parameter only exists for the duration of this call. Okay, so that's the main difference. Okay, the fields are created when you create the object, and they live throughout the object's life until it goes away. Okay, and it's not really by any what I call static scoping. So you can look at this program here and you can tell exactly what is the life of this variable. It exists from here to here. I can statically analyze a program and see that. Whereas I cannot tell what the life of field is just by statically looking at a program, because not only does it exist from here to here, if that variable m gets stored into some other array, even though I may not visually be able to see that it exists, as long as somebody's holding on to that object will live and that field value will stay valid. Okay, so it gets a little bit complex. But remember, the main difference is field variables, fields and member variables are created when you create an object, and they live throughout that object's life. Okay, they are valid throughout the object's life. Okay, they can be accessed by any of the methods in that class, publicly if you don't put private here, or privately through a getter or a setter. All right, now let's go back to the actual question and look at the options. Okay, so does a field take up more memory in the computer than a parameter does? No. So again, it's exactly the same. Let me switch back to Eclipse. It's exactly the same if I declare an int field here, or an int parameter here, or an int local here. They all allocate the exact same amount of memory. The computer treats them the exact same way. Okay, so that is not a difference. A field is a variable that exists inside an object. Well, that's sounding promising, because that's true. A field exists inside an object. Remember, I was talking about that. While a parameter is a variable inside a method whose value is passed in from the outside. Okay, that should all be familiar. What did we just talk about? We talked about how this field is created when you call new, and it exists throughout the lifetime, not between these brackets here, but it exists throughout the lifetime of this object. Okay, whereas this parameter here is created when you call it, it's passed, the value is passed in, and then its life is only exists between these two brackets here. Okay. So yes, this one is true. You can have only one field per class. You can have as many parameters as you want. No, you can have as many fields and as many parameters as you want. Fields are constant and can only be set once. No, that's definitely not true. You can make them public and private, but no, they're not constant. They're definitely variables. Parameters change on each call. That is true, but not this first part. Fields can store many values, while parameters can store only a single value. No, again, whether it's a field or it's a local or it's a parameter, they all use the same data types. Okay, all use the same data types, all access the same, all stored the same. So that doesn't matter. Field syntax differs because they can be declared with a private. Yes, we talked about this. So only a field can be declared with private. Parameters must be primitive types of values, while fields can be objects. So what that is hinting at is, can you declare a field that is not just a primitive type? And the answer is yes. So let's assume we had imported the Java class for point. You can now see point P1. Okay, so they don't have to be primitive types at all. Nor do these. These don't have to be primitive types either. Okay, this could take a point P1 as well. So no, it doesn't matter. And you can use a point as a local variable. And here I've declared a local variable as a class object. Okay, so no, that's not true. It doesn't matter whether it's a primitive type, primitive or object. Java can use primitives or objects anywhere. A field's scope is throughout the class. That is true. And specifically, I was pointing out how it's difficult to see exactly when the field is valid, because if that item ever you lose reference to it, you throw it away, then it stops being valid. A parameter scope is limited to the method. Yes, so you can statically see that a parameter is only available from one bracket to the next. Okay, it's only available here, and you can always see exactly what a parameter is between one bracket and the next. It's only available in this method, whereas the class is generally available anywhere in here, but you actually have to analyze your program to see exactly how long it's living up here. All right, so yes, this one is true. Let's check that. Yes, so that's all valid. So these are complex questions here, but I hope you really understand better now what is between a field and a parameter. I do see this frequently in students that they get confused. It's like they try to they try to treat a field like a local and a local like a field, and they don't understand what's the difference. That's one of the reasons that I always say, when you have, let me undo these changes here. When you have a member variable, you should not take advantage of the ability to refer to these without having to actually use this dot. I always tell my students, use this dot field. Okay, that's so you understand that this is not a local variable. Okay, because it kind of looks like it might be a local variable. No, this tells you that it's not a local variable. When you use this dot, that tells you it's a class variable. Okay. So yeah, these things are very important. So make sure you do understand what these mean, because that'll help you when you're coding. It'll make things clear for you. So if you found this useful, please like and subscribe. I have a complete curriculum on building Java programs, and I have a lot of these practice it programs videos for you.